Hey, welcome everyone. I'm Doug Evans, and we're back again for the last part of a series of webinars we've done called the Connected Project Workflow. This one's going to be Erector and Site Planning. We kind of started this back in April, where we started with the detailer and engineer, and then the detailer with the fabricator, the fabricator working with the Erector too. So it's been a series really powered by SDS2 Edge, which is our cloud platform. And our cloud platform connects the workspace together between sites, partners, and from the field and the shop. So again, I'm Doug Evans. I'm Vice President of North American Sales.
I'm David Zapka, Western Territory Manager.
Tyler Hicks, Technical Sales Manager.
And Nate Block, and I'm the Technical Advisor still.
So we'll get to the presentation. At the end of it, we'll show a demonstration of this in action. So what is the Connected Project Workflow? Like we've said in the past, it's live model interaction by multiple internal and external stakeholders. Whether you're in Lincoln, in this office and across town, or whether you're in Lincoln and have someone in Texas and Florida, all working together at the same time on the same model. That's a Connected Project Workflow. It could be within a company or between companies. You can access and update information. And what that does, it allows you to make informed decisions you couldn't have made in the past because it took too long to get the data and share the data. Now you can just jump into the model and I'll both be looking at the same model at the same time and make decisions. So SDS2 Edge allows those multiple sites and stakeholders to come together and view and manage the workflow across the entire project, which is why we call it the Connected Project Workflow. The stakeholders that can use this and benefit from this: engineers in review, project managers in coordination, detailers can share their model and ask questions and show people what they're doing, fabricators obviously with the shop floor and the field, and engineers and erectors can get information. So today, the last in the series, really steel delivery and job execution, so job site execution. How can I use this technology and be more efficient in my use of SDS2 and in executing the job? So SDS2's 3D model, it's an invaluable tool. You can use it to organize project delivery. You can use it for ordering steel. In this case, it's going to involve many SDS2 products. So we have SDS2 load planning, which some of you may know in the past as Fortosi. SDS approval. We'll use SDS2 detailing, of course. We have SDS2 Erector. And we also have all these partner integrations that you can use. So there's a lot of ways you can use SDS2 both within your office and then sharing that on the cloud and the data all together to make this process efficient. So SDS2 load planning is the first product I'm going to talk about. So what can I do with it? It's really a tool. It takes an IFC import and it allows you to virtually load trailers, which can minimize material handling, and it creates a load map. So you spend less time guessing of what can go on a truck, and so that material handling cost can be reduced. And then it gives you a drawing. So instead of saying, I wonder if this fits, you can just follow the drawing. It's just put the puzzle together. Using that tool, then you can communicate those trailers with the Erector and how you're going to deliver it. So they don't need to guess, again, just using an Excel spreadsheet or a report saying, okay, here's the piece marks that are coming. But they can actually see the actual steel that's going to show up on the job site. And then if they have access to a model, they can click and see where that occurs in the model. It also allows you to reduce number of trucks and trips. So if you're more efficient, if you can get closer to the capacity of that trailer, maybe over the course of a job, you can eliminate a trailer or two. So that's more efficient use of it. It also gives you the ability to modularize the structure in the shop. You can also do that later, as we'll show you in this presentation in the field. But if you're in the shop and you say, I wonder if I can put this group of things together, you can test that. And then if you do able to do it, can you load it on a truck? So maybe you could fabricate it in the field or in the shop and put it together in the shop, but maybe it wouldn't load on a truck. So this allows you to play those games to save everybody time in fabrication and erection. So the SDS2 load planning tool saves time by, again, it provides a visual plan, which is new to our industry, on how you load trailers. And this also saves you time in communicating what is on the load with anybody that would need to see it, whether it's an erector or people in the yard. Obviously, SDS2 detailing. What can I do with that as it gets to job site execution? Well, we have proprietary fields for erectors. You can work with the erector on sequence planning, center of gravity marks for picking things up, That can save a lot of time when you're executing. Weights for modular members, like I said, maybe there's things that you can put together in the shop to save time in the field. We can also incorporate point cloud data. We get into all the different partner integrations STS2 detailing can do, and you can import, if it's a retrofit job, you can import point cloud data to save time and money. So STS2 detailing provides the flexibility to add data, whether it be review information, field information to the model, so members that can execute the project, everybody can look at that. All the different stakeholders can look at that same model that has that data added to it and can make decisions. So it lets you plan the job site instead of react to the job site. And so that is certainly something that we all want to work towards. We also have STS2 Erector. What can I do with that? Well, that's really the ability to add cranes into STS2. It includes things like capacity and reach documentation, placement and pick points, and logistics on the site. So if you're an AISC certified erector, some of this documentation is required, and STS2's Erector tool can do that. You can do site and lift planning documents. You can save those off. And also, as we can in the fabrication office, as far as putting things together modularly, maybe in the field you can modularize the structure as well. Maybe there's a certain group of members you can put together on the ground and then make one lift, again, saving lift. So it really takes the guesswork out of the job site. You can actually plan it and do a erection of it in virtual space rather than in the field. And so you can figure out where your laydowns areas are, what can be a multi-lift or maybe a modular lift, and can the crane hold that up? And also with STS2 detailing, you have all these partner integrations. Erection Bid Wizard, if you don't know what that is, you can take the 3D model and export a file so you can estimate what it's going to cost to erect. We also have barcoding. P2 Systems, a good partner of ours. You can barcode what you're shipping or what's on site, so you can click that and color code the model based off those barcode integrations. Again, with site interactions and interferences, you have point cloud integration. So if it's a retrofit job and you're hanging steel to something that's existing, you can see that. You can incorporate it into the model and see the point cloud data. It allows you to make informed decisions from anywhere, anytime. So again, this can all be accessed in the cloud. You can do BIM coordination on site. So IFCs, CIS2s, you can import multiple trades, whether it be piping or HVAC or whatever you're coordinating with. You can all incorporate that in the same model and view it and see if there's any class detection virtually, again, before you hit the field. Other integrations are with all the CNC manufacturers. We can do scribing of welds. So if there's some field welding, you maybe have a weld symbol with what kind of weld you're putting on it, or center of gravity marks, so you know where to pick things up. Partners are a critical aspect of the entire workflow of a project site. There's many technologies on the job site, and we can integrate. STS2 can integrate with them on a number of levels, and then we can also do that with a live 3D model so everybody can share it at the same time. So again, going back to the connected project workflow, it's live 3D model collaboration. In the past, we've been good at making decisions, and we make them faster. So we're making the process faster, but we just haven't changed the process. So again, I think the future is construction is live 3D collaboration in model space, in the cloud. So you can start refining your process today with STS2 at the center, and then using that data to share it with everybody else. Make more than one user can come together in STS2 Edge and communicate the project and work together. So with that, I will turn it over to David, and he'll talk a little bit about the use of STS2 detailing in the process.
All right, thank you, Doug. Hopefully y'all can see my screen here. Just have a simple basic model. And you know, as Doug talked about, there's a ton of data within these STS2 models that we can utilize to do planning and different things like that. So, you know, just to show you here real quick, since we're focusing on the fabricator, or excuse me, the erector, I have all these what we call custom properties that can be tied to a member. It can be tied to the job itself or individual materials even. But what I want to focus on here today is just the custom properties that are specific to our erectors. So you know, we have different dates on whether a member's been placed. We can come in here and maybe we rejected that for whatever reason. But, you know, simple things that I can do ahead of time before things ever even get to the site are planned, like my erector sequencing. So how the order of the way things are going to go up, or we can do even individual assemblies and specify their individual order of erection. So kind of give you an idea how easy it is to set some of these things. I'm going to turn off the concrete members because I don't necessarily want to focus on those. I'm more focused on steel here. So I can come in here and I can just go ahead and grab all these members, just draw a box around them, hit that properties, and maybe that whole section there is going to be my erector sequence 1. Boom, it's tagged. Now I can run reports, color code that, different things that I want to do to get that information out. I can even take this a step further and set the individual order of erection. So I have a tool here to do that, and I'm going to say add the order of erection beginning at erection order 1. So when I run that, everything that is transparent has not been set yet. So I'm going to just go ahead and start with my columns here. So, you know, I'm just setting, okay, in the field, this is exactly the order that I'm going to place these things. And now I can come up here, set my order of erection for the first floor beams, and just kind of continue on going down this way. So, you know, I'd kind of just work my way up on how I want things to be done. And now when I take a look at those member custom properties again, you're going to see I've got order of erection 3. Remember, I started up in this corner, went 1, 2, 3, and it got that placed appropriately. We can even transfer that information over to the 2D drawings. So if I'm looking at the prints, I'll have that shown on there for each individual member. The other thing this is great for is, you know, maybe I have a scenario where we should have a shop assembled truss. So I need to know the weight of that. I need to know the center of gravity for that to kind of calculate and figure out where I'm going to lift that and if I can lift that. So we have a simple tool in here. When I have that picked, I just hit center of mass, and that's going to report to me where the center of mass is at in the coordinates. It's going to give me the total weight of that. So we're at, what, 5345 there. And you can see we get the little target on screen here shown. Nate's going to use the same truss later on, give us an example of how we might load that and use the load planning tool. We can also do that with individual assemblies. So maybe we've got a different scenario where maybe we want to assemble this particular roof here on the ground and then do one lift with it. So we can use that same center of mass tool, and I can pick the individual members this time. So this would be more like a field assembled deal, and then do one lift. That center of mass tool will work on the individual members or assemblies as well and give me that same information, give me that same target. So I can kind of plan around all of this and figure out how I'm going to lift this thing before anything ever even gets shipped to the job site. So I'll turn it over to Nate here, and he'll go ahead and show you how to take advantage of the load planning.
Okay, thanks, David. Good stuff there. Hopefully everybody can see my screen now. And I basically am working off the same model that David was looking at there. And to get started here, this is basically how we're going to start prioritizing our loads, just working in the model space. And we can use any IFC file type from any 3D modeling software to do this. And from here, we basically just want to be able to filter our members to start looking at what we want to put on our trucks. And we have various filters to do that, whether it be from finish type or material type, whether it be a tube or a column, or you know, your member type as well. So and also piece marks. We can break it down into a lot of different filters. So in this case, I know I'm probably going to want some wide flange members, so I go ahead and start there, eliminate all the junk that's in there, and then probably go ahead and start with some columns and beams, knowing that that's probably going to be the first thing to go up in the field. And so as you can see, it eliminates all that, and now I can start selecting these members to go ahead and start putting on my truck. Let's flip to my trailer. And as you can see, this is a pretty awesome representation of what that trailer is going to look like that I've already built. So believe it or not, I actually used to load trailers and deliver steel to job sites. So this is kind of how I would have done it. Obviously, everybody would do this their own way. Everybody has a preference, but I kind of kept in mind just my longer lengths are going to be at the bottom, kind of working my way up with the shorter pieces. And you can actually see just how tight you can make these trailers to what you would actually be doing in the shop. So, you know, obviously I'm keeping in mind my strap down points, as well as making sure that's a tight load so nothing's gonna be squished together. And what this does is just, it eliminates all the guesswork on your trailers. So as a shop manager, I can hand this information off to the guy in the shop who's gonna be loading the trailer, and he, you know, he's no longer selecting members off his load list and hoping that he can fit them on the trailer. He sees a gap and says, oh, well, here, let's see and try and make this one fit. And then they're flipping, they're rolling, risking a chance of possibly rolling up on a leg. So this eliminates all those safety concerns, as well as making sure you're getting the most efficient load. I mean, you know exactly where those members are on the trailer. And so based off of David's example with the truss, we went ahead and grabbed that truss that he made one modular piece. Originally, it was going to be fabbed up and sent separately, but we already had the conversation with our erector, and he says, you know what, maybe I have space in my laydown yard just for this specific piece here, and I know that I want this, you know, on this load, or perhaps he's going to erect it right off the trailer. So we went ahead and made that a priority. I went ahead and made sure it got on the load, and it's on top of the load, so it's right there for him to pluck right off. And so not only are we just being more efficient with loading our trailers, but we're also factoring in the highest priority with our trailers as well. And we have various ways to export this information. So one export is obviously our load map. So this is the actual documentation you're going to hand to the guys in the shop. And as you can see, it breaks down exactly the geometry of the trailers along with piece marks, so they know exactly what piece is going where on each layer. As we go through each layer, you see the members laying on the trailer and how they're placed. And here's that truss that David was talking about. That's going to be on the top layer. And then it also breaks down your center of gravities. As you can see, we got a rear elevation center of gravity. You can see that this load is pretty well balanced. And then as well as your total weights broken down here, your plan view of those weights as well. And this is also a huge peace of mind for your truck drivers. Nobody wants to see a driver deny a load when he comes to pick up a trailer. You can just simply hand them this documentation, and they're going to have that peace of mind knowing that this load is safe and secure, and they know exactly what that load is. And as well as galvanizers can use this tool. I mean, you don't want to have to send a perfect load off to the galvanizer, and then the galvanizer all of a sudden has to reload it. And he's like, oh, geez, how do I make this fit on the trailer? I don't know how these guys did it. Well, they can have this same paperwork, and they know exactly how to reload that trailer just like you guys did, and don't have to worry about risking maybe a separate load for not being able to get all that steel on the same load. So pretty awesome stuff. Another export here, obviously, is your bill of lading. Breaks down your piece marks, description, your lengths, your widths, those layers as far as where those members fall on that trailer. And then, of course, your total weights. So all that good information. And then the third export would be your IFC model. And I'm going to go ahead and turn it over to Tyler, and he can kind of go in deeper as far as what that third export with the IFC model can show you and what he can do with that.
All right, thanks, Nate. So what we're looking at now is we've gone through all this and we've got it out of the shop. We're looking at the final step here of getting this into the field and what we can do with it there. We've got a lot of different tools in the SDS2 Erector station. The first one I'm going to start with is just cranes. We can do some site placement and things like that. So we're going to add in some cranes. I'm going to come down here and I'm just going to go to crane, and I'm going to want to add a crawler crane here. So I'm going to go ahead and select that, and it'll bring up a list of all the ones we have preloaded. I believe we have about 80 cranes loaded. If we don't have the one you're looking for, we can add other cranes, we can manipulate things, and there's a lot of information contained here inside of the crane that you can make changes to. In this case right here, I'm going to give it a name, and I'm just going to specify what kind of crane we're going to be working with, what's available, what can we get on the site. Now, when I go to load this into the model, you're going to get some instant feedback as far as where I want to locate this. And you can see with this particular crane, I've got some information here coming back to me, and I'm going to go ahead and locate this one right there. Locate the footing orientation, and then we get furthest laydown point. After locating all that, I know exactly where I need to go to be able to lift everything on this job. We had that one, I wasn't going to get all of it, so I'm going to come back in and I'm going to add another crane. And this is just our second crane placement. So we're not going to have two cranes on site. We're just going to have one crane sitting there, then we're going to move it to this point over here. And this will allow us, again, you know, when steel's coming off a truck, we can know where we want to place it where it's not going to be in the way. Just giving you that extra knowledge and chance to prepare up front, so you don't run into headaches out in the field. Now, when I go to add this second crane in, I can see what the first one's going to be able to handle. All right, I can place this one right here, and we're going to be able to get everything on this job. Now that we've got our cranes in, we can go even deeper with this. And David touched on it a little bit earlier with doing the center of mass. We can go a little bit deeper where if we go over to this scenario over here with our hip and valley canopy, and this is something that we want to erect on the ground and just do one single lift, I can come in with the crane tools and I can go ahead and start checking lifts. If it's going to be liftable, I can assign, I can make my plans. So I'm going to do a check assign member lift. With this, I can select all the members I want to lift from a certain crane placement. And we'll get feedback very quickly of if it's going to be able to handle this. So we get in here and we can see all the different piece marks associated with it, the total load weight, what crane we're lifting it from, what line, and we're even going to check the pick and the set points as far as if it's going to be a successful lift. So all these calcs, and this goes back into your, your AISC certified erector, all this information is there. You can be printed out. I can assign this to a placement where, depending on how early you get involved with this and you get that model, you can really have this laid out well in advance of you showing up on site. That's a critical thing that really helps move the project along. You have that information there. The model is the one source of truth when it comes to the fabrication and the CNC and everything coming out. You might as well use that as in many places as you can. And the erector station allows erectors to get their hands in on this model as well. Now, outside of cranes, there are a lot of other good features that go along with this. Reports. We can do, field point-to-point lists. We can do any sort of report from SDS2 you can get into an erector's hands. How you're going to do a shakeout. If you've got certain piece marks, like David had the erection order all set up, we can create reports for that to hand to somebody. So even if they're not comfortable with laying out cranes and putting that information in the model, they can also use this just to gather information. Talking with erectors over the years, a lot of times if they can just know what a piece weighs quickly without having to dig through the documents, without having to go through drawings and look at bills of material, that will save them a ton of time. So we've created some other custom reports just for erectors that allow us to go through here. So these reports will allow us to just circle up any sort of members on the job. We'll take that area there, and it's going to kick this out to Excel for us. Now, this can be sorted many different ways. Again, it's just an Excel file, so you can manipulate it however you see fit as far as, the piece marks, quantities, main material, and what kind of description and the weight we have along with it. So this can be packaged and hand it to guys on site for, the day's work. Here's what we're looking at. We've had erectors use this to just prep the site where, hey, we're going to have a shutdown. We have to have everything staged correctly. And this allows them to go through and stage off of model. So when they show up, they know exactly what they're doing and where everything's at on site. Another thing that the SDS2 erector station is going to do is create that site plan, that crane placement plan. You can come in here and now I can see, hey, I know exactly where things are going to be. I've got a good idea. Now let's start looking at laydown areas. Do we need to worry about overhead power lines? Do we need to worry about where we're going to put the job trailer? All that stuff can be coordinated through here before things show up. Again, just helping you save time and be more productive and hopefully avoid your headaches out in the field and minimize those. That is a lot of the high level of the erector station. What we're going to talk about next is the IFC that Nate created for us. So if you happen to be erecting from, off the back of a truck, or you just want to know what's showing up, we can take that IFC out of Fortosi. And here I'm looking at it in Celebri, and this can be shown on, any sort of IFC viewer. The guys out there can spin it around. They can see what's showing up. You've got piece mark information here by clicking on it. And so it just gives another set of information to people out in the field waiting for the steel to show up, or again, pre-planning, site planning. It's all wrapped into one nice little package here for you. With that, I'm going to kick it back to Doug and finish up our webinar today.
Welcome back. So that was really a powerful walkthrough of what can happen on a job site using SDS2. So you can start at the beginning and look at your shop and what can I put together in the shop and bolt together here instead of doing in the field, saving lifts. Also looking at how can I put it on the truck. So if I can put things together, can I put it on a truck efficiently? And Nate made a great point. If I'm sending it to a galvanizer, there's their map to be able to bring it back so they don't have any guesswork on putting it, saving time the first time you load it, and then also saving the galvanizer time. Additionally, on the site, we can now plan the job site instead of react to it. This allows it to be way more efficient. You can maybe figure out your laydown areas instead of waiting for the truck to get up. So this is really a powerful example of how you can use technology to improve the whole site delivery and the job execution prospect. So again, this has been a webinar series that I hope you've enjoyed and you've been able to get something out of. We started months ago just talking about model review and all the way now down to erecting steel at job site. So thanks again for attending these. Now I guess we'll open up for any questions you guys have.